In this video, I'll be covering question 2, part C from the 2012 AP Calculus AB free response calculator required portion of the exam. I cover parts A, B, and C all in their own individual videos, so if you want to see my other solutions, please check out my other videos. Okay, so hopping into C, we're being told that there is some horizontal line, y equals k, that divides this region R into two regions of equal areas. So it cuts it in half. This one's a little bit tricky. What you want to do here, what I think is helpful, is to remind yourself y equals k. This is a y value. So some y value is going to cut through the middle of this, and we want half of that region to be equal to the other half, wherever that happens. We don't know exactly where it happens, and luckily for us, we don't have to find out all the specifics because they want us to just write this equation but do not solve. So we just need to set this integral up. What we're looking at now is really, you almost need to tilt your graph sort of this direction. We're really looking at a graph that's going up and down now. So we're going to be dealing with things along the y-axis as opposed to things along the x-axis for this one because of this graph y equals k. To set the integral up, we know that the integral is going to go from the lower bound here, because we're talking y values, it's going to go from 0 to some value of k, and that in the end, this has to equal half of our total area. So if you go back to question 1, or part A, excuse me, on this one, if you go back to part A, we found out that the total area of this was equal to, this region was equal to 2.986. And so what we want here is we want the answer to this integral problem to be half of 2.986. So that's what we know going into this. This is the setup. And again, we're not looking to find the final answer, which is why we put the answer in here. The difficult part on this one was really deciding, what should I be taking the integral of? What we have in front of us is the region between two curves. So when we need the area between two curves, that's a different integral setup than what we've done. The integral between two curves looks like the integral from a to b of whichever equation is on top minus whichever equation is on bottom. And in this situation, we'll be talking about y values, so this would be dy. Again, if you kind of rotate that picture this direction, you'll see that this would be the curve that's on top, and this curve here would be the one that's on bottom. So if we're thinking about this region going up and down, that's the top, and the other one is the bottom. Well, we have those. We know then that this right here would be the top equation, and this right here would be the bottom equation. But we need these things to be talking the language of y. Right now, they're both talking the language of x. And so what we're going to have to do is we're going to have to resolve those to be an x equals equation. So we get y equals 5 minus x. You'd resolve that. Go ahead and add the x over, you get y plus x equals 5, and then we would go ahead and just subtract y, and we would get x equals 5 minus y. So 5 minus y is now our top equation. And then we would do a similar game with our other equation. So our other equation tells us that y equals the natural log of x. To get that x by itself, this is where we would want to raise everything to the e. We would say e to the natural log is equal to e to the y. E and natural log cancel each other out, and we would end up with e to the y equals x. So our bottom equation here is e to the y. And now we can see that we have everything we need to do our top minus bottom setup. So the top equation would be 5 minus y, and then we would subtract off of that the bottom equation, which would be e to the y. And this right here, this would be your final answer for this problem. That is the integral that you could set up to find out what that value is. They don't ask us to do it, but that would be what we would have to do if we needed to. This one again was a little bit tricky because we had to start talking about things in terms of y. Oops, I have a dx there. That should be a dy right there. So then 5 minus y minus e to the y dy equals half of the area that we found in part A. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.